Hi friends, welcome to GMK tutorials. So today's topic is registers. Generally guys, you have very aware of that most of the real-time processor like microcontrollers or microprocessors obviously which stores 8-bit operation, which stores 8-bit, which performs maybe 8-bit operation or 6-bit operation. Generally in our basics of flip-flops, everyone having some idea. Flip-flop means that which stores only 1 bit of data. So I think it is very clear, right? So that means if you want to store the 4 bit of data, obviously it requires 4 flip-flops. If you are storing a 16 bit of data, it requires 16 flip-flops. So from this conclusion, I can mention very simply, a register is nothing but a group of flip-flops with a common clock input to store the digital data. So that means register means that we can defining like this. So register is a group of flip-flops which stores a group of information, right? So from this criteria I can mention like this. So a common, why? Because we are mentioned flip-flop is nothing but a common clock means so these are all the sequential circuits, right? Sequential circuits are operated with clock signals only. So that is the important consideration. Okay, na? Sequential circuits. So second one is nothing but based on the arrangement of a flip-flops, these registers can be classified into different categories. Register means that, what is a register? Register is a group of flip-flops with a common clock input to store the digital data. So shift register means that if the shift register is a register which stores the data as well as it shifts the data to the left or right depending upon the signal. So this is nothing but shift registers. So depending on the way of connection of the flip-flops, these shift registers can be classified into 4 categories. That is nothing but serial input, serial output, serial input, parallel output, parallel input, serial output, parallel input, parallel. So simply we can represent SISO, shift register, SIPO, PISO, and PIPO. So these are the 4 categories of the shift register. So coming to the next slide. So this is nothing but serial input and serial output. సో అంటే మనం ఫ్లిప్ ఫ్లాప్లో ఇన్పుట్ ఎలా అప్లై చేస్తాం అండ్ ఇన్పుట్ ఎలా తీసుకుంటాం అనే బేస్ చేసుకొని we can classify this one as a serial input and serial output. So the name itself represents serial input and serial output means that here input is applied to the one flip-flop and output is taken across the last one. That means input is applied the input side of this one flip and output is taken at the last edge, last flip-flop. So obviously if you want to for the serial input and serial output register, first of all we have to store the data, right? So if you want to store the data in all flip-flops, obviously it requires n clock cycles to store the data inside the flip-flops and n-1 clock cycles are required to read the data from the serial input and serial output register. So therefore total number of clock pulses in serial input and serial output is totally 2n-1. So n for loading, n for loading and n-1 for reading. So therefore total is equal to 2n-1 clock cycles are required for the serial input and serial output registers. Okay, next one, serial input and parallel output. So serial input and parallel output means that, so in this case also scenario also here input is applied to the first flip-flop, output is taken across the last flip-flop. So for serial input and serial output, so serial input and parallel output. So in this criteria just output is taken across the flip-flop, not a last flip-flop actually, so corresponding flip-flop itself only. So therefore it requires a n clock cycles to load the data inside the flip-flops and 0 clocks is required for reading the data. So that is a scenario, right? parallel input and parallel output. So in case of the parallel input and parallel output, just we are applying the input to the all flip-flops here at a time. So therefore, data is applied to the all flip-flops at a time with a single clock. Therefore, in case of the parallel input and parallel output, only one clock is required to load the data. We don't require any kind of the clock signal to read the data because of మనం ఇన్పుట్స్ ఏం చేస్తున్నాం, ఇన్పుట్స్ అన్నిటికీ ప్రొవైడ్ చేస్తాం ఎట్ ఏ టైం. సో ఎప్పుడైతే క్లాక్ పల్స్ అప్లై చేస్తామో, క్లాక్ ఎనేబుల్ అవుతుందో ఎట్ ద టైం ఆల్ ఫ్లిప్ ఫ్లాప్స్ స్టోర్స్ డేటా ఇన్సైడ్ ది ఆల్ ఫ్లిప్ ఫ్లాప్స్. దేర్ ఫోర్ ఫ్లిప్ ఫ్లాప్లో డేటా స్టోర్ అయిందంటే ఆబ్వియస్లీ ఇట్ ఈస్ అవైలబుల్ ఫర్ ది అవుట్పుట్స్. ఓకే, దేర్ ఫోర్ వీ డోంట్ రిక్వైర్ some special clock enabling signal to read the data from the corresponding flip-flop. So that's why in case of the parallel input and parallel output, only for n-bit criteria, 1 for loading, 0 for read the data. Therefore, total number of clock pulses is equal to only one clock pulse is needed in case of the PIPO. So let us see guys, very interesting example. Suppose మనం ఒక బస్ తీసుకుందాం. బస్లో ఇట్ ఈస్ ఏ సో లెట్ us see here. సో బస్ తీసుకుంటున్నాను. వెయిట్ ఏ మినిట్. ఒక బస్ తీసుకుందాం. ఇట్ ఈస్ ఏ 3-seater బస్. ఓకేనా, బస్ తీసుకుంటే దీంట్లో సీట్స్ ఉంటాయి కదా, ఆబ్వియస్లీ ఇట్ ఈస్ 1 seat అనుకుందాం. సో సీట్లో మనం జనరల్గా ప్యాసింజర్ వచ్చేసి ఇలా కూర్చోవాలనుకున్నాడు. ఫస్ట్ ఆబ్వియస్లీ ఒక ప్లేస్లో ఫస్ట్ పర్సన్ కూర్చున్నాడు, అంటే వీళ్ళు మూవ్ అవడానికి ప్లేస్ లేదనుకుందాం, అలా అజంప్షన్ తీసుకో. ఓకేనా, జస్ట్ ఇలా వెళ్ళడానికి లేదు, వీళ్ళు షిఫ్ట్ అవ్వాలి, అది ఒకటే పాసిబిలిటీ. సో ఫస్ట్ పర్సన్ షిఫ్ట్ అవ్వాలంటే ఏం చేయాలి, సెకండ్ పర్సన్ వచ్చేసి నువ్వు జరగరా అని చెప్తాడు. సో ఇక్కడ ఉన్న పర్సన్ ఇక్కడ షిఫ్ట్ అవుతాడు. ఓకేనా, ఇక్కడ ఉండే పర్సన్ ఇక్కడ షిఫ్ట్ అవుతాడు. అంటే ఫస్ట్ ఇక్కడికి వెళ్ళాలి, ఒక షిఫ్టింగ్ జరుగుతుంది. ఇక్కడి నుంచి ఇక్కడికి వెళ్ళడానికి 2 shifts, ఇక్కడి నుంచి ఇక్కడికి వెళ్ళడానికి 3 shifts. అంటే ఒక పర్సన్ నుంచి ఈ కంప్లీట్కి 3 seats ఫిల్ అవ్వాలంటే 3 steps కావాలి. సో ఐ విల్ కాల్ ఇస్ ద 3 clock signals, రైట్? సో దేర్ ఫోర్ ఇన్ కేస్ ఆఫ్ ది సీరియల్ ఇన్పుట్ అండ్ సీరియల్ అవుట్పుట్ ఆర్ మేబీ SISO ఆర్ SIPO, to load the data we need n clock signals. Okay, to need n clock signal for the reading the data. సో ఇక్కడే సపోజ్ మనం బయటికి రావడానికి పాసిబిలిటీ ఉంది అనుకుందాం. సో లెట్ us assume that. సో ఈ పర్సన్ బయటికి రావడానికి మీకు ఏమైనా సపరేట్ సిగ్నల్ కావాలా? వీ డోంట్ రిక్వైర్, ఎందుకంటే వాడు బయటే ఉన్నాడు, ఆబ్వియస్లీ ఇటు నుంచి వచ్చేసచ్చు. సో వీటికి ఒక క్లాక్ సిగ్నల్ తగ్గుతుంది. సో రిమైనింగ్ వాడు ఇక్కడి నుంచి ఒకటి, ఇక్కడి నుంచి ఒకటి. ఓకే, దేర్ఫోర్ ఇక్కడి నుంచి ఒకటి షిఫ్ట్ అవుతాడు, ఆబ్వియస్లీ వీడు వచ్చేసి ఉంటాడు. వీడిని ఇక్కడికి పంపిస్తే సెకండ్ వర్డ్ బయటకు వచ్చేస్తారు, థర్డ్ వన్ పంపించేస్తే థర్డ్ వర్డ్ బయటకు వచ్చేస్తారు. దేర్ఫోర్ ఓన్లీ 2 shifts ఆర్ రిక్వైర్డ్, అంటే 3-1, దట్ మీన్స్ n-1 క్లాక్ సిగ్నల్స్ ఆర్ రిక్వైర్డ్ టు మూవ్ ది డేటా ఫ్రమ్ ది corresponding register. It is maybe applicable for left shift register or maybe right shift register. I think it is very clear guys, right? So coming to the next one, parallel input and serial output. The name itself represents parallel input. That means here we are applying the data to the all flip-flops at a time, so parallelly. So therefore we require only one input. Input is applied to the all flip-flops, output is taken across the last flip-flop. ఎందుకంటే parallel అంటున్నాం కదా, serial output. సో క్లాక్ ఇన్పుట్ అప్లై చేస్తున్నాం, సీరియల్ అవుట్పుట్. ఓకేనా, సో దేర్ ఫోర్ ఇట్ రిక్వైర్స్ ఓన్లీ 1 clock టు లోడ్ ది డేటా and n-1 clocks are required to read the data. So 1 for load and n-1 for read. Therefore total number of clock signals is equal to n only, right? So that is the input. So from this we can all the categories we can generalize this one as the total number of clock pulses here. So for SISO, for loading the data, n clock signals are loading and n- for reading. So total number of clock signals is equal to n plus 1. At the same time, serial input and the parallel output case, we need a n clock pulses to load the data. And for parallel output, we don't require any kind of the clock. Therefore, total number of clock pulses is equal to n. For PISO means that parallel input case, we need 1 for load the data n minus 1 read the data. Therefore 1 plus n minus 1 is equal to n. So PIPO case only 1 clock for loading the data, 0 clocks for reading and total. So this is therefore SISO and PISO case only it requires the n clock pulses, right? So that is nothing but shift registers. Okay. So coming to the write shift register. So it is a register consisting of it is also same like serial input, serial output case. So in case of the write shift register, just we are applying the input at left side. Okay, input is applied at the left side and output taken as a right side. Okay, so here just we have to at a 0 clock input. Okay, at a 0 clock input we have to apply the input to the all flip flops 1 is a flip flop 1, just we have to see 1, second flip flop, third, 4 and 4 flip flops look data enter cheyalante. So to load the data inside the 4 flip flops, obviously we need a 4 clock signals. Okay, so but initially you assume that data is already loaded in the shift register. If you want to shift the data from the register, how many clock signals are required is important. So let us see here, initially at clock 0 this is the data is loaded in the register. Whenever the clock input is enabled, at that time it is shifting operation. So the last one is come out from this situation. So this 0 is come outside, right? So when the second clock pulse is enabled, so this one is coming, this one, this, and the third clock pulse 0. So this is a scenario how the data is shifting. Okay, so this is a way where the data is going to be shifted in this write shift register. Okay, I think you have some idea, right? So total number of 4 clock pulses are required to shift the data from, so obviously, so first one is nothing but to shift the data obviously. So last one is already available, right? So we don't require n minus 1 clock pulse is required, right? So initially when the clock pulse is 0, 1, 2, 3. Okay, last one is already available, right? So it initially one click now, second, third. Okay, last one is already available to the last one. Okay, therefore from this total number of clock pulses for this one is obviously n minus 1 is needed for shifting the register from the data from right shift register. At the same time for left case also same scenario, right? Initially 4 clock pulses are required for shifting the data obviously, right? So these two topics will be discussed in the later session, right? So just I have to give you some basic idea how we are going to process the data. Okay, how many required number of clock pulses are needed for this one is also like SIPO case. Okay, left shift register means just we are applying the data in the left side and taking the output across the right shift. Okay, so this is nothing but left shift register. Okay, so this is nothing but wait. So this is nothing but a right side. Okay, this is nothing but a left side. Okay, just we are applying the input at left side and taking the output across the right side. Just we are applying the some initially we are applying the some clock signal to the flip flop. The first bit is shifting from the register, and just you have to take the n minus 1 clock pulses. Initially whenever the clock is applied, the first data is come out from the last bit. So this is a way of process. Okay, so we will discuss in the later session, right? So bidirectional shift register is discussed in the next class, and universal how it is operation performing. Okay, this all will be discussed in the later section. Okay, thank you for watching GMK Tutorials.